from Walchand College of Engineering, Sangli. My name is Harshal Sajara Moraskar and my team members is Praveen Dhondre, Akshata Patil and Aditi Patil. First of all, I would like to thank the Atmel Incorporation for giving us such huge and best platform for the Indian technocrats to develop their ideas, their innovations and show their innovations through the projects. They have invited the All India Innovation Contest, that is Atmel All India Innovation Contest 2014. We have also participated in the contest. So first I thank to the Atmel Incorporation. Now we know that as the day by day the number of vehicles are increasing due to the standard of living of the Indian peoples are rapidly changing. The number of vehicles are also increasing. These vehicles, the main fuel line is the petrol for these vehicles, and also as the number of vehicles are increasing, in proportion with this number of vehicles, the petrol filling stations are also increasing. So we have proposed a great solution which consists of the full-featured petrol pump, that is the autonomous petrol pump. As we know that the first petrol pump, which is the gasoline petrol pump, was invented in the 1885. This petrol pump totally consists of the analog in nature, and it consists of the only electromechanical or the mechanical parts. That's why it consists of the lack of accuracy, and also there are some delays, more delays required to get the actual working from the petrol pump. Later, as the invention takes place, the day by day the nature of the petrol pumps is changing, and now the traditional petrol pumps that is recently we have used in our country consist of the electronics and mechanical parts also. These petrol pumps have some drawbacks also, because the traditional method for filling the petrol is when the customer comes at the petrol filling station, it will first ask the dealer will first ask for the cash, and the customer will have to say for what amount he needs the petrol. Then he have to type the amount on the petrol pump keypad. After that, he will give the petrol, and it also requires some more delay in between this all process. Next one is the accuracy. As we are using the autonomous petrol pump, it totally consists of it consists of the more accuracy. Next one is the number of employees required at the petrol filling station, because as we know that total 45,000 petrol filling stations are now working in the India. Suppose if we take one or two employees at one filling station, then totally 90,000 employees are working on the filling station, and it is the totally human controlled petrol filling station. So we have proposed the solution autonomous petrol pump, which is the full-featured petrol pumps which consist of the high accuracy and fully automated system and self-operated petrol pump. So first of all, I would like to show the protest simulation of my project, that is autonomous petrol pump. Let's move towards the actual. So now let's see the actual simulation of our project. We can see on the LCD it will display the welcome, and it will display the insert key on the display. So insert key means it consists of the key of RF card, because we are giving the RF card, that is EEPROM key, to the authorized person, which will consist of the available balance and along with his mobile number, which is registered at the filling station. So I will provide the interrupt here to insert the key as an inserting key. Okay, so now as I press the interrupt, the key is inserted. The display is showing the wait statement. It will giving the wait statement because it is scanning the content of the RF card. That is the first of all the available balance in the card. Next one is the mobile number that is registered by the user. So we have used this EEPROM key because we are going to send the message through GSM model to the particular customer. Now we can see on the LCD it will show the balance is equal to 3,000 rupees and show card. This command is for the showing the RF card. The RF card is when we show the RF card, it provides the high degree of security, because it will read this 12-digit number from the RF card and provide to the system to give the access. So now we will insert the RF card number on the virtual terminal. That is, we have created the 12-digit RF number. Okay, so now as we insert the RF number, the display will show the valid card, and it will send the message to the particular customer registered mobile number. So it is the now controller is asking for the password. The password is given on the virtual terminal. Now we can see the password, that is 66444. So now we are going to insert the password by keypad. That is 6 6 4 4 4, and then enter. It will show the valid card, and now it is asking for the enter amount, that is the amount for which we require the fuel. So now we are going to give the amount for which we require petrol, that is 0100. Now I have written the 100 rupees petrol. So when I write the 100 and press the enter, that time we can see the motor start rotating, that is the pumping motor start to give the fuel, and we can see on the LCD that is balance is 2900, because initially we have selected 3000, which is deducted by the 100, and which is now 2900, and also the motor will give the fuel to the customer, and again it will say the thanks and visit again.
Greetings from team Rising Thunder. Up till now you have seen why we selected the project called as autonomous petrol pump, the relevance behind the autonomous petrol pump, as well as you are now familiar with the simulation process that what we have done in the software called as Proteus. So you are known with what components that what we are going to use, but let's see in hardware that what actually we are going to use it and what it does look like. So here you can see the whole project over in front of you. It contains the project is made up of different devices and different components. So let's see those components one by one first, and afterwards we will see the whole demo of our project. So let's start with the main part or the heart of the project called as a microcontroller. So this is the microcontroller made up of Atmel. The name of microcontroller is 89S52. The reason behind selection of this is it is very user friendly, easy to use, and the function that what we are required for this particular project is satisfied with the help of that particular controller. So now let's move towards the LCD screen. The LCD screen has been interfaced to the microcontroller to its port 0. The LCD that what we have used is 16x2, that is 16 characters and 2 lines. After knowing the LCD, let's move towards the keypad. The keypad what we have used is 4x4, that is 16 keypad. That keypad is being interfaced to the port 1. Afterwards we will move towards the RF reader. What does RF reader significance is there in our project? As you know that we require to show the RF card. The RF card what we will show would be read by the RF reader, and when the RF reader reads the value, that value is being sent to the controller via serial port, and after sending that value to the controller will check whether the data that has been sensed by the RF reader is the same which is stored in the EEPROM. Now let's move towards the GSM module. So the GSM module is used to send the password to the customer to its mobile. So whenever you insert the key and afterwards showing the RF card, you require to insert the password, and that password would be sent by GSM to the mobile. So you can see over here the antenna of a GSM. So that is used to send the password to the mobile. So you can see the mobile over here as well. Okay, so this is the RF card. After that, where you have to insert the key. So this is the key, and this key you have to insert to here. That is a key insert over here. So this is an EEPROM IC which is being connected over here, and this EEPROM IC should be connected to the key. So what actually the fundamental is done between this is the EEPROM IC is connected to P 2.0 and 2.1, as well as we are going to provide an interrupt with the help of the key. So when it will provide an interrupt, then it will check whether the key is valid or not, and if the key is valid, then it will be proceed further. So this is the whole circuitry. Now from where we are going to pump up the petrol. So you can see here the petrol tank. So here we have connected the petrol pumping motor. So in this petrol tank, you can see the blue color, it is a petrol. So that petrol would be pumped through the pumping motor with the help of the pipe, you can see that the fuel is been inserted into the bottle. So this is the whole circuitry that what we have designed, and you can see that it's been enclosed into a single case. Okay, so let's brief in what all we have seen. That is first microcontroller, after that LCD, then keypad, then RF module reader, after that GSM, EEPROM key interfacing, and petrol tank. So this was the all hardware description of our project. Thanks. Okay, so now you have seen the hardware description of our projects. Now I think you are awaited to see the simulation of our project. Now let's move towards the simulation of our project. So I have the EEPROM key into my hand, and I am the customer. As customer, I would have to insert first the EEPROM key into the EEPROM key socket. So I am inserting over here the EEPROM key. I have inserted the EEPROM key. As soon as I have inserted the EEPROM key, the display will show the indication that is wait. So what all it does when the indication is wait? The EEPROM is been read by the microcontroller, and the microcontroller will read the valid EEPROM key number as well as the phone number which is been written into the EEPROM, and the amount, that is balance. So it will show the total balance what is there into the EEPROM. So the total balance in the EEPROM is 2000 rupees, and afterwards now it will show that show card. So this is my RF card. So this is my RF card, and I required to now show this RF card to the RF module. Now I will show this RF card. As soon as I have shown this RF card, the display shows that the RF card enter was valid, and afterwards it will show that enter password, and that password is been sent to my mobile through an SMS. So this is the password, that is 38582. So I required to now enter this password through the keypad. So now let's enter the password through the keypad, that is 38582. After entering the password, press. After entering the password, now the display shows enter amount. Now customer has to enter the required amount into through the keypad, so that it will pump the that particular fuel. Okay, so now I'll enter the amount. So I want to enter the amount 100. So 0 1 0 0, and after that I will press E2. After pressing E2, the remaining balance would be displayed, that is 1900 balance, and the pumping action would take place. So now you can see the pump is on, and the fuel is being inserted into the petrol tank. Okay, so the system is defined in such a way that for a particular amount, the particular delay is generated for the motor, and that particular amount of fuel only is inserted in or only being pumped out. Okay, and after completion of the whole process, it will show done, and again the system will resume, that is from welcome and insert key. So here we have seen the overall demo or overall working of our project. That's what we are going to do actually. So that is inserting the key, showing the tag, entering the password, afterwards entering the amount, and then taking out the petrol. So for designing this whole project, we have guided for us, that is our electronics department, as well as our project guide, Mr. V.R. Gaikwad. After that, our HOD, that is Dr. Mrs. S.S. Deshpande, and I would like to specially thank to Mr. Prakash Budharkar and Pradeep Tondikar. Thank you.